Good day, students. Today I want to solve problem on relative density involving piece of ice. What you need to do is to analyze your question. Relative density of ice. Let's use RD ice to be equal to 0.92. Okay, let's say when ice, okay, let's say V1 equals volume of ice piece, equals to volume of ice piece, that's V1. Okay, V2, let's say equals to volume of ice piece immersed in water, is like that. V3 equals volume of ice piece immersed in liquid. Okay, because we have water and liquid, and when ice floats on water, we have the condition that weight of ice equals weight of liquid displaced. Okay, the weight of ice is equal to weight of liquid displaced when it's being immersed in water. We're referring to water. This one is water. Okay, you can see water. In that case, don't forget that the formula, when you're dealing, you see that in this question we are given relative density of ice, okay, to be 0.92, and we have relative density of liquid. We'll get to liquid. Okay, now since you know that relative density of ice equals we are dealing with mass. If you are dealing with mass, you can say we are dealing with weight of ice over weight of equal volume of water. That's the formula. Now if you are looking for weight of the ice, since you are equating to this, now weight of ice equals relative density of the ice. Okay, let's put ice there. The ice multiplied by weight of equal volume of water. Since you have it like that, you now have relative density of ice to be 0.92 multiplied by what's the volume of equal volume when you are dealing with ice, piece of ice, V1. Okay, now we now equate it. That's why we'll be using this and equate it to that of the water. Okay, there's the relative density of that. Now since we are giving that of ice, I will give you relative density of the water. Okay, that is, take the density of water as this. Okay, we now go back and insert it to this expression. 0.92 times V1 equals that of water, which is 1 times V2, volume of ice immersed in water, V2. Now, since you are dealing with a piece of ice will be submerged when floating in water, it will be V2 will be up, this V1 will be down because it's being submerged in water. Divide both sides by V1, divide this one by V1, this cancel this, you have 0.92 equals V2 over V1. Therefore, V2 over V1 equals 0.92, which is equal to 92 over 100. Okay, so we have to look for what fraction of the volume of a piece of ice will be submerged. This is the fraction that will be submerged. Let's see when ice floats in liquid. When, let's say, this condition 1, the second one, when ice floats in liquid, that means that weight, in that case, weight of ice is equals to weight of equal volume of liquid, equal volume of liquid displaced, liquid displaced. Okay, water, in this case water displaced, but in this case it will now be liquid displaced, because we are referring to when it floats, ice floats in what, in liquid. Now, since it's like that, weight of ice, we still go back. Since we are dealing with the weight, relative density of the ice, 0.92 times V1, volume of ice piece, equals weight of equal volume of liquid displaced. What is the relative density of the liquid? Since we are dealing with liquid, okay, relative density of the liquid, density of the liquid liquid multiplied by its volume, that's V3. Okay, and to now be 0.92 times V1 times density of the liquid, giving us 1.11 equals to 1.11 times V3, being immersed, submerged when floating in liquid. Still be under V1, being submerged in liquid. This cancels this. You have 0.92 equals 1.11 times V3 over V1. Divide both sides by 1.11. In this case, 1.11 cancel each other. Therefore, V3 over V1 equals 0.92 divided by 1.11. When you divide that, you have 0.83. Now let's turn it to fraction, because that's expressed in terms of fraction. 83 over decimal is 1. How many figures after decimal? 2. Add to 0. This is the fraction that will be submerged in liquid. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.